Okay, good afternoon, everyone. Can you all hear me well?
Yes, ma'am.
Can anyone tell me you can hear me well?
Yes, ma'am.
Yes, okay. So let's start the session. So we are in the course of MTM 21212. It is a numerical analysis 1. So we are in the chapter number 1. It has 2 sections. First one is a number system and errors. Next one is solution of equation in one variable. So let me finish the number system and errors as possible. So people are asking recording the meeting. So for now it is deny. Okay, so wait for me. I need to get the permission from the head of the department. Okay, so from the chapter number 1, number system and errors, we have almost finished all about the number systems, ways, how it is. There are 2 main things you have to keep it in your mind. One is the fixed point method, and which is using the integer part, decimal point, and fractional part. Similarly, there is another one we call floating point form, which has the multiplied by power of 10 base 10. Okay, similar wise. Okay, we have finished all these. I think we have stopped here. Yes. So we have stopped in this error measurements, ways of the types of error. Third one, error measurements. We have seen how to find the absolute error, relative error, and percentage error. So let's continue from this. Okay. So the fourth one, please change whatever I have changed in your module from mine. Okay. So you better take short notes with the heading and write down the whatever I'm writing as a main point. Also write the examples like that. Then you can using the module as well as your rough, you can make a good notes with your in later. So when you're studying, you can make up the notes very well. Okay. There are only 84 people. Where is the others? Tell them to join quickly. Okay. So errors in computation. Computation means it's about the computer, maybe any calculate as well. We can adapt that one. Okay. So mainly the computer. Okay. So errors may occur during data input to a computer. So there are some error kind happens when it is come to the computation in the computer, because of the memory value. Some computers accept some number of significant values. For example, one computer may accept only up to the number 8 significant figures, or 4 significant figures, like that. Calculator can have like, for example, 5 digits only, like that. Okay. So if it is so, we may encounter so many errors in our actual computation. So in that case, how we can find the the errors. Okay. So if you know how the errors, we can find how much we can tolerate. Tolerate means, so I said you in early yesterday's lecture, like for example, your value is, for example, sorry. There is something wrong. Okay, give me a minute. Okay, so for example, if you have the value 2.59 plus or minus 0.01, like that. Okay, this is a tolerance. This much plus or minus can, like 2.59 or I mean 5, 8 also acceptable, and 3 also acceptable. That's the thing. So this is we called as a tolerance. This much we can accept, okay, tolerate. So you can see, so in this way, the decimal floating form. Okay, I already told you the floating form and fixed form are a little bit, you have to consider this one. Floating form has a multiplication of 10th power. Okay, so it has, let's say a real number has been written in this way. For example, okay, let me erase this one first and write nicely. Okay, so let's say your this is your value. For example, x equal to 125.38109, like that. Okay, so times 10 to the power minus 3. So it means actually it is like this 120 0.12538, like this number we have, right? This is a fixed point number, so this is our floating point form. Okay, this can be stored in the computer in this way. So this one can be stored this way. For example, we use the computerized things for, computerized form for x star. Okay, so x is our true value. This is the thing computer accepting. So you see the differences here. Okay, so that is something. Okay, give 1 second. I couldn't write. Okay, so this is x is our value, what true value. This is our computerized value. Okay, this is the thing you have to consider. So these values are up to m. Okay, so this value is up to w. Maybe these two are same. See the differences. So m and w. Okay, also these values also changing. D1 star, because we are considering for the x star. Okay, so this m is called as a word length, as well as w is the computer word length. For example, only we can write our value, right? For example, 15.2356, whatever, like we can get like this values, okay, for our actual value. But computer accepting, let's say, only 8 digits. So how many we can have? So 106.2356, that's all. So maybe this one 952 is continue like that, but we can have only this part. Okay, so here these kind of these may be affecting our actual experiment, isn't it? This is something, it will affect our thing. So that's why here w and m are, m is our up to, this is up to m. For example, let's say 15 digits. Okay, this is only 8 digits. Okay, so there are 7 digits are remaining. So that's what it say. Maybe sometime m may be, like for example 4, computer may be 8. For example, let's say 0.1256 times 10 to the power minus 1 something, and computer can accept 1256, even the more than that. Okay, if it is so, what will happen? That's what we're gonna see. Okay, I will explain the example. Okay, now, okay, so there are two situations we can encounter here. Those are, why I couldn't draw. Okay, wait. Okay, so let's see, there are two situations we can handle. Okay, one is w can be greater than or equal to m, and w may be less than m. Okay, in these two situations, how we can calculate our things, that's what we're gonna see now. Okay, so if w greater than or equal to m, then there is no error. That means x equal to x star, di can be equal to di star for everything I is equal to 1, 2, and di is equal to 0 for I is equal to m plus 1, m plus. Okay, that's what I have explained you. Okay, I'll explain what it is now. Okay, for example, my m is equal to, m is equal to 4. Okay, w is equal to 8. So I am writing 0.1256 times 10 to the power minus 2. Okay, so what in the computer it will take like this 000 times 10 to the power minus 2. See, so when you are subtracting, this will be our x star, this will be our x. So x minus x star will be, we have 000 something, isn't it? So no errors. So if it is this situation, w greater than or equal to m, we will have no errors. So that is obvious. Okay, for example, we can see, please write down whatever I'm writing if you want to understand clearly. Okay, so they said okay, so in this also you can see all the other up to infinity. Okay, infinity means all the di's are 0, where this m plus 1, m plus 2, because up to m we are equal 1. So likewise I put like 1, 2, 5, 6, 0, 0, 0, 0, it goes, no? So up to how many w may be 8, w may be 15, w any number. That's why they put like infinity. Okay, any number. What is the value of w? It can all the other values are 0. Okay, so up to xi will be equal, other elements are 0. That is what it means. Okay, so let's see the example. For example, x equal to 0.321. So only we have 4 digits. Significant figure will be 3. Okay, so so therefore in the floating point number you can write this one as a 3.21. So you are taking the decimal this side, so 10 to the power minus 1. Okay, so x star also, sorry, this should be x. Okay, take out this one. So x star also same, nothing happened. Okay, in the fixed point number, also in the floating point number they have given here. Okay, this is a fixed point number of x, this is a floating point of x, these are x stars both. Okay, now okay, now the next situations. So we have seen, okay, what will happen for sorry, w greater than or equal to m, there is no error. Okay, what will happen for w less than m? It means what? The computer digits is less than the our actual digits. For example, our digit is, let's say, 1, 2, 5, 7, 8, 3, 2, 1 to the power 10, 10, 2 or something. Okay, so w only having 4 digits. Okay, so 4 digit 1, 2, 3, 4. There must be something up to this one, this value. We have to take out this one. So it may take giving so many errors. So that's what we're gonna see, right? So in here, error will occur on storing the number xi, which is also called a storage error. Okay, because of the memory of the computer, we are having some we are having some errors, so which called as a storage error. So in here, x not equal to x star, di not equal to di star for all any m. Okay, so what will happen in the calculation? So let me check in the next. Okay, let's see this example. Okay, for example, okay, okay, if you see this example, what do you think? So x is equal to 0.1256875354. There are 2, 4, 6, 8, 10 digits. Okay, this is our actual answer. So what about this one? 2, 4, 6, 8, only 8 digits. So we here take off this value. Okay. So the computer itself will be giving some approximations. So it has cut the computer itself cut the remaining part and giving only the 8 digits. Okay. So this is something we're gonna see what will happen. Okay. Let me clear this one. Okay. Now let's continue. This computer use one of the above algorithm for input the number as the approximation called chopping. Okay. So it means if this according to the computer w greater than or equal to m, w less than m, we will have some algorithm. Algorithm means the computer has it's written in the instructed to do these things. Okay, so it's doing two methods to cut this out. Okay, if you're giving 10 numbers, it cuts 8 numbers. If you're giving 4 numbers, it is also 4 numbers with zeros 4. Okay, these are something the computer itself doing with the algorithm they have given. Okay, so it's called, there are two approximations algorithm which calls chopping, and next one is a rounding off. So let's see what it is in detail. Okay. Okay, if you see the first one, let's see the chopping one. So chopping means what in just in English? Chopping means cut. Okay. So let's see what it is, how to cut this one. So the simplest mechanism of storing x when w less than m, because why we are considering only w less than m? Because if it is w greater than or equal to m, there's no error, so no need to consider. The remaining element will be 0. That is not a problem for us. So this is the problem things, w less than m. So if you're having this problem, to store the x, it's ignore all digits after dw. Okay, called chopping. So for example, so as I said earlier, if you have, for example, 0.12568, let's say 84321 to the power 10 to the thing. So 2, 4, 6, 8, 11, 8, 9 digits. So if you want only 5 digits, it's ignoring all these and giving the answer 12568 times 10 to the power 2. It doesn't think about these values. Okay, it's just cutting, chopping and ignoring the other values and giving the answer, taking this for the calculations. So that is what we called as a chopping. And it's after the dw, it means what? Our dw will be 5 digit, let's say. So after the 5 digits, it will cut off all the remaining part. So and let's see one example. Okay. Okay, check this example and see whether you understand it. Okay, what does this example says? This is our actual value, okay? X equal to 45.293. They are asking to chop, okay? This chop X, this one to 4 digits. Okay, but in the chopping, what we do? First of all, what is doing is the computer making it into the floating point number, from the fixed point number to floating point number. So you have to take everything after the decimal number. So 45293 can be written as 45293 times 10 to the power. So we are taking this side. So it means 10 2. Okay. So if you are taking this side, the 10 power will be plus. If you are taking this side, it will be minus. Okay, I think you all know all these things. So they are saying 4 digits. So 1, 2, 3, 4. So you have to cut here. So this will be chop off. So the answer will be 0.4529 to the power 10 to. So we are giving it's in the fixed point form, like this form. So when you multiply by 2, 10 to the power 2, it will be 45.29. Okay, so that's what it says. Okay, this is a computational output. Okay, so can you try the next question and give the answers in the chat box? Likewise, fixed point to floating point and cut off the 5 digits and give it in the fixed point number. So I'm expecting everyone to answer me in the chat box. Only I think 1 minute's enough for everyone to answer. Do the second one and answer me in the chat box. Okay, I'm getting some answers. Okay, let me see. That's good. So hope you all very good in fixed point and floating point way. Okay, just writing in the multiplication of 10 power. Okay, good. I'm getting some answers. Yes. So if the question in the fixed point form, you give the answer also in the fixed point form. If the question in the floating point form, you give the answer in the floating point form. So like that, okay? So, okay, good. I'm getting enough answers. There are some correct, there are some wrongs. Okay, so many corrects. Okay, let's see the answers. Okay, it's very easy, nothing to worry, okay? So you have to write it in the floating point number. So you have to take this side the decimal. Okay, so if you are taking this side the decimal, it will be plus 10 to the power. So we are taking 1, 10, 2, 3. So 10 to the power 3. Okay. Then we have to chop 5. So 1, 2, 3, 4, 5. So you have to cut out this one. So the answer will be 0.63129 to the 10, 3. Then when you're writing again the fixed point number, multiply by 3, it will go this way. So 631.29. So these are school level calculations. I hope you all know these things. Okay. Okay, good. Let's continue. Okay, can you try the third one? It's not a big deal, but just for the practice. Okay. Try the question and answer me so I can check whether you understand. Answer for the 3. Okay. Mhm. Okay, good. I'm getting some good answers. Okay, let me show you the answer. So you can see the answer if you want. Okay. Okay, one more thing. In my account, I couldn't get the full time 2 hours lecture. So they are giving only 40 minutes, 40 minutes. So it's okay. Like yesterday, we can join again. Okay. The same link, you can join again if it is end. Okay. So within 10 minutes, it will be off, and then you can join again. Okay. This one is very easy. So okay, not a problem. So they have because this one it's in the already fixed point without the multiplication of 10th. So they are making into something. Okay. So you can write like 45 point something to the 10 to the power minus 2. Oh, this is also fine. Okay. They are making something floating point. Then they are taking out, I mean, 3 digits. So it will be like after this one. Yeah. So 1, 2, 3. After this one, they cut out. So the remaining answer will be something 4.52 to the power 10 minus 1. So this will come this one. So you need to take this side. So 0.452. Okay. So I get okay. Everyone's answer are correct, I guess. Okay. Check your, if it is wrong, please correct your answers and write the reasons also. Okay. Okay. Now let's this is already I have explained. Anyway, the absolute chopping error is delta is equal to this one. We have seen yesterday also. Okay. So this means yes. So delta is equal absolute error. Delta is equal to modulus of x minus x bar. The modulus coming, even though plus or minus, it will give us a plus answer. So if you x minus x star for the chopping error, the absolute chopping error, see, until something dw, you will get the 0, isn't it? Because you will get the same. For example, until the third digit, you will have the same. See, this one and this one are same. Only thing is you have these, after this one only it is changing. So that's what they say. Up to dw, here up to dw, it will be 0.0000. Then after dw plus 1, dw plus 2, up to whatever the m, it will come as a remaining numbers. So hope you all understand. For example, let's say, let's take this example. Okay, x is equal to 0.4291 and x star will be, final answer will be 0.452. So what is the absolute error for this chopping error will be x minus x star, which is equal to 0.452 minus 0.4591. This will be negative 0.000 remaining 91 something. Okay, 91. Okay. So because of absolute one, you'll get the positive 00091. See how many zeros? We have 3 digits. So here W will be 3. So up to 3 we have 0. After W is equal to 4, W is equal to 5. All these elements are any numbers. Okay, any number dw plus 1, dw plus 2. So in here you see 2, 4, 6 numbers. So 2, 4, 6 numbers. So it goes up to how many m numbers. Okay, so that's what it says. Hope you have understood. So from this writing this example again under here, you can understand this one, or you can choose any example to understand this part. Okay, until the digits 5 or 4 up to that 0.000, then the remaining number will come. How many number? Up to m numbers. Okay, here up to w numbers. These are we taken as dw plus 1, dw plus 2, like that. Okay, so hope you all understand that part. Okay, let's move to the next thing. Okay, there is 2 notes there. Okay, so what it says is upper bound. Okay, upper bound means upper bound. So maximum Okay, maximum error can be. For example, the chopping error, you will have something, but this much of can be tolerable. I told you already, this much can be acceptable. Okay, tolerable or acceptable. Tolerable or acceptable. Okay, this is a maximum point. So more than this one, we can't because that's why they use this one. Okay, delta can be less than, not equal also. Okay, less than this much of error. Okay, so what is the 10 n minus w? So what do you think n? We know m is the word length, actual values word length. W is the computer's word length. What is n here? Anyone? Can you answer me in the chat? At least one person. Can we take a 0 time, for example, 3? Yeah, that is also correct, but 10 to the power 1, okay? Okay, 10 to the power 1. Oh, mostly we don't take 10. It's better you take, 10 to the power minus 1 or any minus power. Or if it is more than 1, it is better to take 10 to the power 2, 4, 3, like that, okay? So anyway, if it is answer is correct, that's fine. Yes, n is a chopper, not a chopper. N is a power of 10. Yes, good. That is the idea, answer. Okay. So what is n here is, see here, actually 10 to the power n is, sorry, wait. I'll erase this part. Okay. Then here you can see 10 to the power 4, 10, that is a different case, no? 10 to the power n. Okay, this part. Okay, keep it in your mind. This n is a power of, okay, wait. Yeah, this one is the 10 to the power n, any power you are taking for the multiplication for the floating point. Okay. Okay, now, so hope you get the idea. What is m, what is w, what is n? Okay. So here they are saying upper bound for the chopping error will be, wait, upper bound for the chopping error will be 10 to the power n minus w. So we know w. So n is, what is the multiplicative of decimal 10? Okay, 10 power. Okay, so they're saying this in this word, this is a formula. Okay, upper bound for absolute chopping error is this one. It means delta can be less than or equal to this part. Similarly, for the relative, what do you mean by relative error? Can you tell me? What is the formula for the delta? We have seen yesterday at last. Yesterday class, last section, we have seen this one. What is the delta? So answer me in the chat. I got one answer. Okay. Relative array, yes. What is the formula? Okay. X minus delta divided by mod x, yes. Not mod x bar, x, no? I think we have to go here. Yes, this part. Okay. Check this out. Okay, delta is modulus of x minus x star. This is